So the complaint today is that it keeps blowing the transformer. We have a short circuit on the 24 volt side. So what I did was I started taking things out of the circuit until the transformer stopped tripping. I narrowed it down to when I would add power to this module, the transformer would trip. So then I started taking things out one by one, and I was very suspicious of this heat wire. There's a 4 conductor here that had power in common from the transformer, and then it had this green wire was tied in with W2 and the white wire was tied in with W1. And I've just never seen a valve like that before, or a heat kit, right? So I just got here, I didn't know if it was electric heat or hot water or what. It turns out it's hot water. So I've just never seen a hot water valve that needed power in common and then 2 24 volt signals. So I figured that's probably wired wrong. They do exist, actually. Here is an example of one type of floating actuator that uses 4 wires. You've got power in common to keep the motor in position at all times, and then you've got a wire for driving clockwise and a wire to drive it counterclockwise. The reason it needs power in common constant rather than just a common is because this is a fail-safe actuator. So it's got a spring in there that will return it to its original position in the event of a power loss. So typically we see 3-wire floating setup. So it'll have a common, and then it will have the wire for drive it counterclockwise and then drive it clockwise. But if you only had 3 wires and you didn't have that constant power source to lock it in place, if you wanted to give it a floating command and send it to 50%, so the stroke time is 90 seconds, 50% of that is 45 seconds, so the controller tells the clockwise terminal, it's going to send a signal on the clockwise terminal for 45 seconds, and the motor will drive to 50% and stop. Well, if there's no spring to return it to 0, that's fine. That works just fine. But if it's fail-safe and there is a clock spring in there, you've got to have a constant power source to lock it in place, or else it's going to drive back to 0 and it's going to defeat the purpose of being floating. So then I find that the hot water valve is over here. It's a 4-pipe system. You got the hot water valve on this side, and the hot water valve is a Johnson Controls, and it is a 0 to 10 volt signal, and it tells you on the inside which terminals are which. It needs power common, it needs a 10 volt signal and a 10 volt signal common, and it tells you which terminals, and here they are. So we have this, they tied in with W1, and this green one they tied in with W2. So you got power and common coming to the actuator, and then you've got power and power, which is not correct. What's even more baffling is I found the book right next to the bad wiring. Like, hey, please read me. And here it is, down on the bottom, tells you exactly how to wire it in. So another fun thing is that they had the common of this ice cube relay in Y2, and the signal of the ice cube relay in Y1. So the Y1 part makes sense, but the common being stuck in Y2, that doesn't make any sense. So I've installed a Pearl that's going to handle it a lot better. We've got 2 modulating actuators, one for chill water and one for hot water. I put the hot water valve 0 to 10 volt signal in A1 and the chill water valve in A2. And you got a common for the hot water valve. It's a Johnson Controls product, and it needs the common. The chill water valve is a Belimo, and it gets its common through the transformer common, so you don't have to run that one back. We've got the supplier temp tied into T1 instead of the TA1. So they used to have a TA1 to pull in the supplier temp, but the Pearl has it all nice in one package. So made it a lot easier. So you just have a fan call on one side, and then you have the chill water and hot water valves on the other side, and the supply air temp coming in to modulate those valves. You do need your supply air temp in order to modulate your valves properly. And now all I have to do is send an email to Pelican support and have them configure A1 and A2 for modulating chill water, hot water valve. Now I'm just testing this heat actuator, and look at that. Running that worm gear up. Worked like a charm. I was afraid that having 24 volts hooked into the 10 volt terminal would fry the thing, but it does not appear to be fried. So on this unit, this valve was wired as modulating. This valve was wired as floating, even though it came with the booklet right there in the control section for you to read and figure out how to wire it. 0 to 10 volts right there. Now this other unit right next to it, this valve was wired as floating, and this valve was also wired as floating, even though both of them are modulating. And so we need to know about these Belimos, right? Like these we don't encounter very often. You can still look up the model number. It's right there on top. VA 7152-1001. And you can find the booklet, the manual for it, and figure out what it is. But these Belimos are way easier. You just read it. Like right here, I know it's upside down, but it says the input voltage is 2 to 10 volts. And pretty much anytime you see SR, so 24-SR, more than likely is going to be 2 to 10 volt signal, or 0 to 10 volt signal. And again, you can just Google this model number, and the data sheet is available from Belimo every time.